Okay, this next set of videos is around single subject analysis called AFNI start to finish, and we'll basically use AFNI proc.py to run a full first level analysis, a full single subject analysis from pre-processing through linear regression, and then at the end hopefully we'll run a simple group analysis with results that would have come from this. So just to get everybody on the same page, let's close this handout for now and we'll open it together. So CD and LS, so I'm sitting in my home directory and I have AFNI handouts and AFNI data 6, and let's just open this handout. This is AFNI 16, and I'll use AFNI open to do it. AFNI open, AFNI handouts, AFNI 16, and then hit tab. So I can hit AFNI 16, that should be a unique prefix, and then I can just hit tab to have the shell finish the rest of the name. Again, as a reminder, AFNI open is an AFNI program that, in this example, it sees it's a PDF file, and then it goes looking for PDF viewers in the path and just uses one to view the document. And at least that allows us all to start on the same start with the same command. So this intro slide here shows actually shows ubersubject.py, which is a graphical interface to AFNI proc. We don't currently really use it that much because it has a limited set of options in AFNI proc.py. However, it's a reasonable place just to get something to run, just to start getting a feel for things. You know, its main job is to generate an AFNI proc.py command. In the future, I will probably make some major updates to this to make it a little more useful again. But right now, we don't really use it. We want to focus on AFNI proc.py. So what do we imagine as our goal? So you can imagine starting you're in a new group, you're collecting some data, or you're thinking about collecting some data, and your goal is, essentially to run a group analysis on some single subject response magnitudes. Say you're going to stimulate the subjects while they're in the scanner, and we'll try to get estimates of the magnitude of the bold responses to our stimuli, just to make some claims about how the brain may work. And once you get these beta weights for each subject, you want to run some group analysis. So how do we get there? Well, the beta weights are volumes of numbers that are in our case probably going to be bold percent signal change units. So we want to get these beta maps for each subject. They should be aligned across subjects if you're going to run some group type test, and they should be aligned probably to a well-known template. Typically, you might have an atlas in mind that you care about, and so the template should be well aligned to the atlas. And so when you align all the single subject data to this template, anatomical template, then it will be aligned with the atlas. A good example of something that doesn't work so well with that is the Tayloric atlas that does not have any template that's well aligned to it. There are some templates that we say are in Tayloric space, but none of them are actually well aligned to the Tayloric atlas. So there are better atlases, or at least there are atlases in Tayloric space that are aligned to a template that are more reasonable to talk about. But anyway, there are lots of atlases in Tayloric space or AFNI space, and there are many AFNI spaces. There is not just one. But anyway, so you pick an atlas and then a template that's in the space that you're happy with. If there is an atlas you like a lot, but there is no template, but the template that is aligned with that atlas is not in a space that you care about, you might be able to contact us to see how you might get that into a different space. But that's beyond this course right now. So once you get these beta maps for each subject in a common space, then you can run the group analysis program. And we'll focus on 3D t-test++ here, but of course, whatever program you're going to run is fine. So now, how do we create these aligned beta maps? Well, more particularly in the olden days, you'll write a single subject processing script. You would have that do pre-processing through the linear regression. Again, pre-processing, possibly t-shifting, maybe many volume registration steps, blurring, scaling, whatever. And then it runs the linear regression, say using 3D deconvolve or 3D remel fit. And the inputs to that processing script, it will start with data inputs. You might have the anatomical data, the EPI for each subject, and the stimulus timing that's particular to that subject. Possibly other things, other masks or, field map or blip up, blip down, distortion correction data sets. There could be other inputs, but these are the basic ones. And then that processing script will have some control options that you've specified, like the blur size and the alignment template and things like that. And then the output from this should be those beta weights, beta weight maps that you want. The output should be beta weight maps that are ready to go into your group analysis program. Along with those, you'll get t-stats, contrast, blur estimates, lots of quality control data sets and pieces of information as well, but the main output is the beta weights. And the other things are just there to basically make you confident that the beta weights are useful. So, how does one write the single subject pre-processing scripts or the full processing scripts? Typically, we'll use AFNI-proc.py. That's its job. We tell it what our input data sets are, we tell it what choices we've made about how the processing should be done, and it writes a single subject processing script in T-shell syntax, and of course it can run that as well, or you can run it yourself, either way, but its job is to write this processing script. And then if that's the route you go, you might consider including the AFNI-proc.py command itself, maybe in the supplementary section of your publication along with the AFNI version, and those two pieces of information will make it very clear exactly what processing was done to get your input data sets into the output format. Again, note that the AFNI-proc command itself is typically not very long, between 20 and 50 lines, depending on how many things you tell it to do or how many inputs you give it. So, it's not very big, and that provides a tremendous amount of information. The processing scripts that it creates are meant to be very clear records of the processing, so you should be able to look at them and see exactly what they are doing. Sometimes there's some shell syntax involved, and that shouldn't be too confusing. It's meant to be as clear as possible, and it comes with comments. So you should spend some time looking at those and seeing exactly what is done, so you understand the processing steps. None of this should be magic. If anything feels like magic, then you should just spend a little more time learning about the actual step that's in question. So for this data analysis that we're going to run, you might picture this experiment as your own. Feel some responsibility in how it's being carried out, including the choices that are made for processing. And you might imagine you're entering a new lab, for example, and you're going to help run an analysis, but so you have some data in hand, but you want to view the choices for the analysis that are made by you and your colleagues as ones that you feel justified in using. Typically, you'll want to make the choices before acquiring any data, but for now, let's just pretend we're being handed the data. Note that there is no single correct way to analyze data, just reasonable ways. How to do it depends very much on the experiment in question and how the data is acquired, how big the voxels are, so many things. You have to think about the data that is being acquired and make some choices about how is reasonable to analyze it based on that. Even for data in a known acquisition, you can still bicker about basically any pre-processing step endlessly. So for the most part, you want to understand the analysis well enough to feel justified in the choices that you have made for processing. So for now, we'll focus on understanding the processing steps given the choices that were made. And as always, you want to practice the good habit of reviewing results. Do the initial images look good? For at least some of the subjects, you want to review each processing step along with the data in detail, which is basically what we're going to do in this set of videos. Are the anatomy and EPI well aligned at the end? Do the resulting statistical maps make sense? There will be a lot of quality control output that can be viewed to help make these choices. But for at least some of the subjects, a few of the subjects up front, you should look at them in detail. And then later on, maybe you can focus more on the HTML quality control report that's produced at the end. So we'll start out by creating scripts for any of the processing steps. Note that that's more than just the single subject analysis that I'm talking about here. I would create scripts for absolutely every step that is done. They are your records of how the data gets processed. If you're asked 6 or 12 months after an analysis, so exactly how did you do this step? It's not good enough to say, well, I don't know. I opened the data sets in AFNI and I pressed the buttons. I forget exactly what I did to get that last step right there. But anyway, I used a GUI to do it, and I had some notes about it on some piece of paper that it was eaten by my goldfish. I'm not quite sure where it is. You don't want to be in a position like that. Just script everything. You can use graphical interfaces to manipulate the data, play with commands, get a feel for what should be done, but in the end, everything you do can be moved to a script. And then there's no question about how to analyze the data. The scripts are also very easy to apply to new subjects. It's much harder to remember all the buttons to click. You just script things and then you're done. They should be easy to repeat, and notably, you should expect to reanalyze all your subjects. You made a mistake in some choice. There's a new decision. For example, you've decided, well, actually, I don't want to blur in my single subject analysis because I'm going to use the ETAC option for 3D t-test++ to do to basically deal with all the voxels and the multiple comparisons issue, and it'll do the clustering and it'll do multiple blurring levels, and so I no longer want to blur at the single subject level. So anyway, you might make a choice like this later on, and you want to be able to just start over. Maybe you'll decide that you need a new cost function for registration to do a better job for some reason based on your data. And then you keep all the original data and all the processing scripts, and then you can effectively repeat the analysis anytime. That also actually goes along with being consistent about the version of the software that's being used. You might update the software regularly, But once you've basically acquired all your subjects, it's a good idea to reanalyze all of them with the current software to one set of software, so you don't have 2 years of data acquisition using 2 years of different software versions to run the analyses. So typically, you'll repeat all of the subjects, basically all of the subjects at the end anyway. So before we review the stimulus conditions, I think I'll just stop this video and we'll start a new one at that point. Thank you.